Hello ladies and gentlemen, welcome back. This video tutorial is for students who are in Geometry Goal 5. We've talked everything we need to about perimeter, and now we want to talk a little bit about area. Area actually comes, you can kind of tell, in a couple of different spots because we have area for other types of shapes. But for now we're going to look solely at squares and rectangles and get ourselves used to those first. So let's dive in. So not the layer I wanted to see. Give me a second here. All right. So now we have area of a rectangle on a grid, and area for any kind of rectangle is going to be, up until now you've always learned it as length times width. Because of how the shapes are going to play out later, we're going to change that to base times height. It means exactly the same thing. You have a base and you have a height. The same way you have a length and you have a width. It is exactly the same thing. So in this case, that is 4 times 4, which is 16 units squared. This is going to be 2 times 3, which is 6 units squared. Like, really that easy. You probably got this right on the initial knowledge check. Area of a square, that is again base times height. And since this is 6, this is 6. 6 times 6 is 36 inches squared. I don't even need to write anything down. Let's see here, since this is 7, that means this is 7, base times height. 7 times 7, that's 49 centimeters squared. Don't forget your units of measure. Distinguishing between the area and perimeter of a rectangle. So now they almost want us to think. So area is length is base times height. So that's going to be 97, and then that's going to be 73, just in case. Now, what I need for this, I'm good, but I'm not that good. Let me find perimeter first, because that I can at least do in my head. So that is twice the length plus twice the width. At least this computation is easy. That's 146 plus 180, 194. So that's going to be 200, 330, 340. So the perimeter is going to be 340 feet, and now I have to do the multiplication, and I'm just not that good. So once I have my calculator, it's going to be 73 times, what is it, 97. 97 equals 70, 81. 70, 81 feet squared. All right, the strip of tape will be placed around the courtyard. Around is your keyword. That's going to be the perimeter. The courtyard will have a wood floor, which means the entire space. So what you're looking for, around means you're tracing your way. Having the wood floor means you're filling it in. So this one is going to be area. Next up, let's see here. So that's 72, and then that's 92. So that is going to be twice 72 plus twice 92. Wow, these are really similar. So 144 plus 184 is going to be 325 for perimeter, 325 feet. And now let's do 72 times 92. So 72 times 92 is 6624. So 6624 feet squared. So the computation isn't that hard. Court will have a wood floor, that's perimeter. Tape will be placed around, that's perimeter. Isn't that the same problem? That's exactly the same wording. Okay, I'm going to assume that they'll have different wording for this, because apparently my screen grabs were playing with me again. So, area of rectangles with the same perimeter. Okay, so same perimeter but smaller area. There's an actual cheat for this. Okay, I want to explain it first, but there's a difference between having a bigger area and a smaller area. So the rectangular field is 60 meters wide. So when we're looking, so we have 60 and 105. What's happening is that we want the perimeter to be the same. So if 60 plus 105 is 165, you have to pick two numbers that add up to 165. Now, I don't want to just pick a random number and then figure out whether or not the area is going to be bigger or smaller. Here's the trick. You know when they say something is squared, you know that handy little thing, like feet squared or inches squared? What that means is length, it's base times height, right? That's what it means, a number times itself. Well, if you think about it, let's think about this for a second. If we want a smaller area, that means if you've ever paid attention, this was something the Egyptians kind of figured out back in the day, and then a little bit into the Middle East when they were working through their algebra. If you have a really big disparity between your base and your height, you're going to get a smaller area, which means these numbers need to be further apart. That's the hack. And if if you want a bigger area, they need to be closer together. So since I want a smaller area and Ms. Dubois is lazy, I want to have these just a little bit further apart. So I'm going to change it to 59 because I'm going to pull 1 out here and I'm going to add it in here to 106. So they're a little bit further apart, which means the area is going to be a little bit smaller. Here we have 80 and 125. We want smaller area, so we want it further apart again. So I'm going to pull 1 out and then add it back to the other number. That's all I'm doing. If it was bigger, I would do the same thing, only make the numbers closer rather than further apart. Next up, a couple of word problems. Oh, I know, don't even. I hear you moaning, it's fine. So let's see here. We know that this is a rectangle, so I'm just going to immediately start off and draw a rectangle before I even read the problem. Okay. Glass window, the window is in the shape of a square. Oh, okay, so let me make sure that I know it's a square. The side lengths are 8 feet, and then suppose it's $6, per square foot. Well, since this is a square, the area is 8 squared, which is 64. It is $6 per square foot, so divided by 6. So what is 64 divided by 6? I'm pretty sure that divides not evenly. So $10.66. So $10.67. That's what we are looking for. Wallpaper in the bedroom. Bedroom is in the shape of a rectangle, or at least this time I read the problem before I drew the picture. Ms. Dubois. Let's see here. Length is 12, width is 11. It's $9 per square foot. Okay, so 12 times 11 is 132 divided by the $9 per square foot. So 132 divided by 9, that's not going to divide evenly. 14.67. So that's going to be $14.67. It doesn't say anywhere here about rounding, so I either just didn't copy it in my screen grabs. If you guys figure out that it's rounding to a different thing, like the nearest whole number, let me know in the comments. All right, algebraic expressions for the figure. This is the last topic of the family. Let's see here. There's our setup. Find the area of the following: the light rectangle and the dark rectangle. Okay, so light rectangle is going to be 5 times 3, which is 15. Dark rectangle is 5 times x, which is 5x. Let's see here. Give the area of the entire figure in 2 different ways. Okay, so the sum of 2 areas and then the product of the length. So first up, the sum of the 2 areas, that's these 2 pieces. So it will be 5x plus 15. The product of the length of the 2 areas. So there's my 1. That is going to be x plus 3. And then there's the other one, 5. So that's what they're looking for you to get used to. One is, think of it as one of them, which will be before distribution, and one of them will be after distribution, which is conveniently how this is set up. So over here, the light triangle, 8 times 3, which is 24, and then 8 times x, which is 8x. So sum of 2 areas is 8x plus 24, because there are the 2 areas. We just went through the effort of finding them. And then product of the length, so it will be 8 times x plus 3. That's what they're looking for. So that is everything to do with area of the most basic of shapes, which is squares and rectangles. Before I get into the other kinds of shapes, we want to talk a little bit about mixing and matching and getting used to perimeter and area kind of all in one go. As always, stay happy, stay healthy, stay safe. I'll see you in the next one.